Okay, welcome back. Part 3 of our What is Calculus series. So we're going to put the rate, time, distance, velocity applications to the side for a little while. And I want to focus on another aspect of where we can see calculus in everyday life. And of course, we are certainly not limited to speed problems. It just so happens that that is one of the most common and most recognizable applications, but certainly not the only one, as we're going to see here. Okay, so let's read through the following application problem. A theater company is currently selling 1,000 tickets at $15 each. When raising the price to $25, attendance fell to 600. So part A, find a linear equation relating the number of tickets sold, and we'll call that S for sales, to the price charged, X. So far, that's a problem we tackle in elementary algebra. In the Math 91 course, we see part A. But what's new are the second two parts. We're going to find the price X that will maximize the revenue. Anytime you find any type of problem where you need to find a maximum or minimum of something, that's usually something you're going to use calculus for. And we're going to, again, use very similar methods here. And C, find the actual maximum possible revenue. So before we even get started here, let me just kind of illustrate what we're kind of going after here. So you have sales and you have revenue. So we're presuming that if you're not selling any of a product, you're not making any revenue. Again, we're talking about revenue, not profit. Obviously, if you were giving something away for free, you still have the startup cost, so the actual profit would be negative. So by revenue, I'm just talking about what we would refer to as gross sales. So there comes a certain point where you've made as much money as you're going to make, as feasible for that situation, because what's going to happen if we keep raising the price, that's actually X for sales, for the price. If we keep raising the price, what's going to happen is eventually the price will be too high and you're going to lose all the sales. No one's going to want to buy the product if it's too expensive, and you'll lose money that way. So there is a maximum point here. And in algebra, we call that a vertex. It's basically a maximum or minimum point. So that's what we're ultimately trying to find, but we're not there yet. First, we have to find the sales equation before we can even bother with the revenue equation. So let's tackle that part first. So if you remember from algebra, when you're trying to come up with a linear equation, the first thing you need to find is slope. And so the slope is going to be y2 minus y1 over x2 minus x1. That's just like we've done before, except the y value in this case is sales. So I'm going to put, instead of a y, I'm going to put an s. And let's see what we have in this particular case. So we need two XS instead of XY, XS pairs. Well, we're given that information, right? If we have a $15 selling price, we have a $1,000 ticket amount. If we have a $25 selling price, then we have sales of 600. So that's exactly what we're going to do. So we can take the difference in sales over the difference in price, and we have negative 400 over 25 minus 15, so that's going to give us 10, and that's going to give us negative 40. So that's our slope. And again, it's important to understand, and I always stress this, stress the importance of this. It's important to understand what meaning the slope actually has here. Slope is a rate of change. We say that in algebra, we say that in calculus. So we're relating a change in sales for a change in price. So we could say for every $1 increase in price, sales decrease by 40. Negative 40 is decrease, that's why it's a negative number. So we need to find the linear equation resulting from this, and so we'll use our point slope form and plug the numbers in. So we have y minus, we could use either point here. I'll use the, I think we'll use the 25 and 600, although we could use the 15 and 1000. For some reason, this seems like the slightly easier choice. Oh, that's negative 40. And the x1, what was that, is 25. Okay. And we can multiply everything out. So we have negative 40x, 25 times 40, well, that's negative times negative. That's going to result in 1,000. And add the 600 to both sides. So that's our equation. And actually, I've got to change that to s. Remember, that's r. Okay, so that's our equation. That is the equation that relates the selling price to the number sold. I should say, I keep putting S. S is the number sold. Okay, so this we've probably seen before, but what we had not seen is what do we do from here. So we've gotten part A. We have a relation, an equation relating sales to price. But now what we need is to come up with an equation. Before we even find the price that maximizes revenue, we need to find the equation of this parabola first. So let's start. Let's think about what revenue is. Revenue is the number of products you sell times the money that you take in for each product. So if you're taking, if you have 500, let's say 500 tickets sold at, let's just say 20 each, then the revenue is going to be 500 times 20. That's 1,000, and then you have to add the other zero. So that's going to be the result. That's the amount of sales. So let's, the amount of money we make. So let's go ahead and write an equation. So the sales, well, what is the sales? Well, the sales, we actually found that earlier. That was the equation. That's going to be the negative 40x plus 1,600. So that gives us the sales, and now the price each, well, that is going to be our x. Remember, x is the variable we used for price. So the revenue then is going to be negative 40x squared plus 1,600x. And that, oh no, it does not complete part B. That only gives us our revenue equation. but we're getting there. This is going to be the equation. So this is the equation that's going to give us this parabola up here. So the next question comes, okay, well, how do we find the price, the value of x that results in the highest possible value of r? That's what we're ultimately trying to find. That is the question that we're still trying to answer. Okay, so let's first of all, let's actually visualize this. Let's see what that graph would actually look like if we were to plot it. So let's go ahead and draw the graph here. So we got we're going to let this be price X, and I like to put revenue. So let's plug in some numbers. Let's make a table of values. All right, so, well, if we have zero price, then we're not going to make any revenue from that. We can put in $5, and that will get us $7,000 in sales. So I've already computed these in advance to save some time here. But all we're really doing, I'm taking values of x and plugging it into this equation. So $10 ticket price will result in 12,000 in sales. 15 price, 15,000 in sales. This is all money. $20 ticket price. The revenue still increasing, just to a lesser amount. So it looks like it's it's reaching its maximum right around 20. Now, we can't just come to the conclusion that the maximum occurs at 20 just from this table, because there's a possibility. It's easy to say, yes, 16,000 is the highest revenue of all the numbers we plugged in, but how do we know that the revenue isn't 21 or 19 or 18? It could be somewhere in between. It could go up. Revenue could go up to maybe 17,000 in the middle here, and then go back down to 16,000. So it's looking like 20 is our candidate, but we cannot definitively state that just by examining this table. It gives us a rough idea, though. And so let's go ahead and plot. So 0, 5, 10, 15, 20, 25, 30, 35, 40. 40 because that's going to be, if we raise the ticket price to 40, no one's going to buy any tickets at all. That's probably not quite the case, but it's what's going to work for our model. Okay, so 5. Oh, and let's make a scale here on the r-axis, I should say. And let's see, we seem to have a maximum of about 16,000. And maybe we'll just kind of subdivide this as best we can. Okay, so 0, 0, we already have that. $5 sale price will result in 7,000 revenue. $10 will result in 12,000. $15, about 15,000, so we're just under 16,000. 20, it seems to be the maximum. 25, again, we're down to 15,000 again. Once we get to 40, we're back down to 0. So let's kind of trace this through. It's not the best drawing here, but All right, so again, this is our target up here. So how do we actually find it? This is where some more of those calculus tricks come in. Now, if you've taken intermediate algebra, you may be aware of a formula, negative b over 2a, that you can plug in the numbers from a quadratic formula. And it's a nice quick way to find it, and that formula can be derived using the same method that we used in the first two lessons. But the problem with that formula is, this is the Vertex Formula, which some of you may remember from intermediate algebra. The problem with that formula is it only works if you have a quadratic equation. So you have to have the ax squared plus bx plus c. If it's anything that's out of this format, then the Vertex Formula is not going to work. So it's convenient, but the cases in which it can be used are very, very limited. So we need a more general approach. So let's kind of take this, and I'm going to kind of redraw the graph from arbitrary values here. So this value, so here's x, here's r. I'm going to put some arbitrary number. This is a. And we're going to say that at x equals a, profit is maximized. So, given that, this is the question we have to ask. Let's remember what we did with tangent lines and slopes. Remember, if we take a value and if we look at the derivative, the whole process of finding that slope, we can find the instantaneous slope at any given point by finding that tangent line. Well, let's focus on what happens. What can we say about that tangent line when we're at a maximum? Has a zero slope. Right? That's going to be the key. We want to find the value of x that gives us a zero slope. So again, let's think about this. So we have the slope, we have that slope of that tangent line. If the slope is positive, then profit is increasing. If the slope is negative, then the profit is decreasing. But at zero itself, well, it's a transition between increasing and decreasing. So if it increases until it can't increase anymore, then it starts to decrease. That's what we want to zero in on. No pun intended. So that's our goal. So here's what we're going to do. We're going to basically do the same process as we did before. Find average slope. From x equals a to x equals a plus h. once we simplify, we set h equal to 0, and then solve for x if the slope itself is 0. So the setting h equal to 0, that's what we did in the first couple of lessons. So if you still need some refreshing on that, you might want to go back and watch the first 2 videos when we went through this process. But it's going to be the same process that we did for the instantaneous velocity, except this time it's instantaneous change in revenue. And we want to zero that out to find the maximum. All right, so let's go ahead and do that then. So let's recall what our equation for revenue is. Our equation for revenue is 1,600x minus 40x squared. That's the equation we're trying to maximize here. So let's set our slope. Let's see what values we're going to use here. So x1, x2, r1, and r2. So x1, that's the point A. That's the point we want to try to find. Right? X2, remember we take that value h and we add it. R1, okay, so this is going to get, the algebra is going to get a little more complex here. R1, well, R is equal to 1600. If I just take A and plug it into this equation, we're going to get 1600A minus 40A squared. R2, okay, this is going to be, we're plugging in A plus H instead of A. So like I said, the algebra is going to get a little dicey here, but stay with me. 1600 A plus H minus 40 times A plus H squared. Okay, so let's find the slope then. This is going to be a kind of a tedious process, but I'm going to go through this as many steps as I can. We're going to have, first we need to take R2 minus R1. So we need to take the 1600 A plus H minus 40 A plus H squared. And then we can subtract the R1, that's 1600A minus 40A squared. And then I have the x2 minus x1. Well, that's just simply A plus H minus A, so that's going to cancel out to H. All right, let's do this. Let's go ahead and see what this comes out to. Okay, so we could distribute the 1,600. That gets us 1,600 plus 1,600A plus 1,600H. Now we can square the binomial here or use FOIL. A times A, so that's going to be A squared, and we're going to distribute the negative 40 to that. Then we have, if we have A plus H times A plus H, we're going to have AH, right? So we're going to have minus 40 AH minus another 40 AH. And then I have an H squared. Again, we multiply that by negative 40. And now we distribute the negative sign on this end. We get minus 1600A plus 40A squared. Still with me? I know, I could have made this with smaller numbers, but it wouldn't be realistic. I want to try to keep the numbers to what you would see in an actual situation. So that means some algebra here. Oh, by the way, when doing these types of applications, this is generally not how you're going to find the slope. The process I'm using right now is a very manual process. In an actual calculus class, you would learn some shortcut methods to do this by, but I can't really show you those shortcut methods right now. So we're going the long way around, but please don't assume that all calculus is going to involve algebra this intense. Some of it could be more intense than this, but you're going to be using generally simpler methods to find the slope. Okay, But the good news is we have a lot of things that cancel out. I have a 40a squared and a minus 40a squared. We have a 1600a and a negative 1600a. Oh, we didn't take the we didn't subtract the minus 40 and minus 40ah, right? So we need to combine those two still. But let's see what we have. We have 1600h minus 80ah minus 40h squared. Everything else cancels out, and now we can pull out an h. It always looks rougher in the middle, but once you start reducing terms, now we can cancel out the h's, and so the slope is going to be 1600 minus 80a minus 40h. Okay, so remember, to find instantaneous slope, which was the instantaneous velocity before, the velocity is slope, the instantaneous slope, that requires h equal to 0. So let's go ahead and do that. And finally, let's remember, our goal is to get that slope equal to 0, as we saw above. So we set this equal to 0 and solve for a, so we get 1600 equals 80a, and a equals 20. So our suspicion is confirmed. We can now show that $20 ticket price will maximize profit, or maximize revenue. I kind of use those terms interchangeably. Technically, profit is revenue minus expense. For our purposes, they're kind of the same thing, at least for what we're doing here. So after much ado, that is the answer to B. That is the end. And again, you're not going to be, all calculus is not going to involve this much of a process. The process I'm showing you here is a very direct definition, process by definition. In calculus, you'll learn all sorts of shortcuts or ways to find this equation much quicker. But we can't just stick to the vertex formula, as I said, because the vertex formula only works when you have ax squared plus bx plus c. As soon as you put it in x cubed or in something over x or a square root, as soon as you start putting any of those things in there, the vertex formula is useless. So that's why we do have to go through this process, although there will be easier ways to do this when you actually get into a calculus class. Okay, so the last part, that gives us the $20, that's the price that actually maximizes revenue. So we still need to determine what is the max revenue. That's actually the easiest part of this question, because all we have to do is plug in $20. A equals X. $20 is the X value that gives us the maximum revenue. So 1,600 times $20 minus 40 times 20 squared. And once we compute the solver, 1,600 times, so 116, this is 32,000. And then I have 40 times 400. So it's 32,000. 32,000 minus 16,000, and that's where our $16,000 comes from. Okay, well that brings us to the end of this lesson. Of course, we covered a lot of ground here. Just to recap, so we started with the process of just finding the linear equation. From there, we went to turning that linear equation for sales into a quadratic equation for revenue, and then we went through a lot of general explanation here, general theory, And then finally we say, okay, once we have the revenue formula, then we find the slope of the tangent line, which we did in this process here. Set that slope to 0 and see what x value we get, and finally plug that x value back in to find our actual maximum revenue. All right, a lot of ground covered today. What I'm going to do in the next and probably last lesson for now is I'm going to go into that vertex formula a little bit more and try to figure out where that vertex formula in algebra actually comes from. Thank you for watching. I'll see you next time.